So last time we started talking about rational expressions. We multiplied and divided our rational expressions, and mainly it was just an exercise in factoring. And factoring is still going to be part of what we do today when we talk about adding and subtracting our rational expressions. And so we're just going to go kind of slow through this because I know that this is probably the least favorite topic in the whole of this unit. So ask me any questions you need to. I know adding and subtracting fractions is not fun even when it's just numbers. So what do we need? You know, hopefully remember this from all your time in middle school and high school doing it. What do you need in order to add and subtract a fraction? You have to have what? Same denominator. You got to have the same denominator. Okay, you got to have your common denominator. So my first two examples, I've got that common denominator. Example one, this is an example with numbers just to kind of get us maybe somewhat comfortable or looking at something familiar. I've got 3 over 11. I've got 5 over 11. I've got the same denominator on both. So once you identify that you have the common denominator, what's the process for adding fractions? What do? You add the numerators, you leave the bottom alone. Okay, so 3 plus 5 gives me 8, and 11 remains the denominator. I do not add the denominators, it's not 22. Okay, so add the numerators, leave the denominator alone. So what we're going to do is we're going to expand our little worldview here, and we're going to do the same thing with algebraic fractions. Okay, so again, once you have the common denominator, you either add or subtract the numerators and leave the denominator alone. So my next example, right to the right, says I have 7 over 2r squared minus 11 over 2r squared. Are the denominators the same in this problem? Yes, quite obviously they are the same. Thank you for saying yes anyway. And so now I'm just going to do the arithmetic. My numerators, I've got 7 minus 11, that's negative 4 over, and you keep the denominator the same, so 2r squared. So this is actually the second thing you'll do, but it's the first thing we learn, that once you have the common denominator, the process hopefully is nice and relaxing. You add or subtract the numerators, keep the denominator the same. So page 1, this whole front page, that's what we're going to practice. So ask any questions you need to about this step of the process. So I'm going to give you about 30 seconds to do exercise 1. And also remembering, you know what, I didn't do something. Maybe you were wanting to call me on it, but I'm just talking too much today. Then thinking back to what we did last time, we always reduce our fractions. Is there a factor in common to the top and the bottom of this fraction? Yes, 2. 2 goes into negative 4 and leaves negative 2. And then 2 goes into 2 and leaves 1r squared or just plain old r squared. So don't forget to reduce like I was about to do. Learn from me and my mistakes. So exercise 1, go for it, 30 seconds. All right, here goes. Again, you identify we have the common denominator. 5x squared is the same on both. So I will add the numerators and keep the denominators alone. So 6 plus 14 is 20 over 5x squared. If you did that, you're half done. You did a great job. That's the adding. That's the new bit for today. The end of this is just what we did last time. So reducing that, what factors in common to the top and the bottom of this fraction? Yeah, 5 goes into 20 4 times. 5 goes into 5 1 time. And so I get 4 over 1x squared, which I'll just write as x squared. Give exercise 2 a try. Notice that the top is not like terms. Okay, that's my little hint to you. And if you don't get exercise 2 when we go over it, that's okay. Don't beat yourself up. Exercise 3 is going to be the same sort of thing. So once again, I have the exact same denominator. Okay, common denominator. They're both x plus 4. No need for any changes or anything. So the first thing I'm going to do is I'm going to add those numerators and leave the denominator alone. So 3x plus 12, when I add those, what do I get? Are they like terms? No, so we keep them separate. So there's kind of a trick question. Sorry, I'm feeling a little spicy today. It's 3x plus 12. That's what you get when you add those together. Okay, not like terms. That's why I gave you that little hint before you started the problem. And again, don't beat yourself up. I know it's cold today. Your brains aren't quite firing just right. So you'll get your chance to redeem yourself on the next problem if you miss that. And then I'm going to put it over x plus 4. So there's the adding. That's the new bit for today. Okay. Now we're going to go back to what we did last time. We got to reduce this. So can I factor anything out of the top? Is there a common factor? Yeah, 3. Perfect. Thank you. And so when I factor a 3 out of the top, 3x, I factor out 3, I have x. 12, I factor out 3, I have plus 4. Oh, look at that. Tricky Perkster. Do I have a factor in common to the top and the bottom? For sure, that x plus 4. So I'm going to cross it out. And what's left over is 3. What part of the fraction is the 3 left in? Numerator. So you can write you could write the answer as 3 over 1, but we don't tend to write ones in the denominator, so we'll just write 3 as the answer to that because it's in the numerator. All right, well, from whatever you learned from that problem right there, reminder about collecting like terms and factoring, do the same sort of thing on exercise 3. So when I do my first step, again, I notice there's a common denominator to both of these. So when you add or subtract, you just add or subtract the numerators and you leave the denominators alone. So my numerator is going to be x minus 3. Those are not like terms, so it's just going to stay x minus 3. Divided by the denominator is x squared minus 9. So if you did that, you are doing a great job. You are almost to the finish line. The rest of this problem is just doing exactly what we did last time. So hopefully you did your homework and you're caught up on, you remember your factoring. So when I do that, I have x minus 3 over x squared minus 9 is a cute little difference of squares. Difference of squares is x plus 3, x minus 3. And once again, I see I do have a common factor. It's not going to happen every time, but it does in these first few problems just because I wanted to remind us about reducing that we talked about last time. It's my way of reviewing what we've already done. Okay, so now we notice the x plus 3's cancel. The x minus 3's cancel. Where's that x plus 3? Denominator. So when I write my answer, I have to write 1 in the top over x plus 3. That's required. If you've got a question, please ask it. I know adding, subtracting is not always our cup of tea. So if I'm not doing a good job or you need something from me, let me know. Otherwise, start with exercise 4. All right, once again, I've got the common denominator, so I'm going to add those numerators. I'm going to leave the denominator alone. So when I add my numerators, I've got 5x plus negative 3x. What's 5x plus negative 3x give me? 2 of them, for sure. And then I've got 6 plus 4. 6 plus 4, I've got enough fingers to do that. That's 10. The denominator stays the same. That's x squared plus x minus 20. If you did that, you've done the addition. You've done the new material perfectly. Well done. The rest of this is just review of what we did last time. It's reducing that fraction. So out of the top, how can I factor the numerator of this fraction? You can factor out a 2. Yes, thank you very much for that good advice. 2x divided by 2 is x. 10 divided by 2 leaves me plus 5. In the denominator, I've got a trinomial. Okay, so I'm unfoiling it. What 2 factors of negative 20 add up to plus 1? Okay, 5 and 4, which one's positive? Which one's negative? Perfect, said with confidence, and I love it. 5's positive, 4's negative, because they got to add up to a positive 1. And at that point, we say, oh, yes, we do. We've got a common factor in the top and the bottom, so I will cancel it, meaning they divide out and give me 1. That's what canceling is. We talked about that last time. And I have 2 over x minus 4. Just to make sure you're still awake and with me, can I cancel that 2 into the 4? X minus 4 all goes together. It's either all or nothing when you have binomials, okay? So you can't just cancel bits and pieces of binomials or trinomials or anything. Okay, great, well done. One more of these, just to make sure we're feeling nice and confident. And if you're not nice and confident, help me help you. Okay, so exercise 5 is the one right below. I am going to give you a hint. Notice this is a subtraction. The most common mistake students will make, okay, so I'm just trying to clue you in, is you will subtract the 3x and you'll forget all about the negative 7. So what I recommend you do is distribute that minus sign, that negative, through all the terms here at the top. That's my recommendation, just like subtracting polynomials. Okay, so you probably remember from arithmetic that when you subtract things, it means to add the opposite. Okay, we've talked about this before in our Wayback Machine first day of class when we were simplifying the expressions in our equations. So what I'm going to do, just because sometimes I do things real fast and I forget details, so that I do not forget that I am subtracting everything. What I'm going to do is I'm going to change this to a plus and I'm going to distribute the minus sign. So it's going to be negative 3x and then it's going to be plus 7. Okay, that's what I meant about distribute the minus sign. Okay, make sure you change the signs on everything in that polynomial that comes second when you're subtracting. That way you don't make probably the most common mistake made on this test. Okay, so I'm just trying to alert you so that you do not do that. So what you should have in your numerator once you've done that is 8x and negative 3x is 5x. And then 13 and 7 is 20. It's usually that second term that sometimes students miss, or a lot of times. If you have a plus 6 here, you didn't subtract the whole thing. Okay, so it has to be plus 20. Over the x squared plus 7x plus 12. This is just like the previous problem. What can I factor out of the numerator of this? Yeah, that 5. That 5 is in common to both terms. 5x divided by 5 is x. 20 divided by 5 is 4. The denominator is a trinomial, so I'm going to unfoil it. What are the two factors of positive 12 that add up to positive 7? Sure, 3 and 4, 4 and 3, the order absolutely does not matter. And so what I end up with here, is 5 over x plus 3. All right, so let me pause. That is what in the process of a problem, that's actually the second step, but it's the first thing we did to introduce the fractions. When you already have the common denominator, you add or subtract the numerators, leave the denominator alone. How do we feel so far? Okay. Takes practice. It takes you asking me questions if you have them. Okay, so feel free. Now, what's going to happen now, I'm going to do my next example, and what we're going to see, okay, I've got a fraction. I don't have the common denominator now. So I'm going to have to figure that out. So this becomes the first step. We have to get the common denominator so we can do just what we did on these 7 problems that we just did. Okay, so I'm going to tell you about finding common denominator. Actually, in my opinion, finding common denominator in algebraic fractions is a little more straightforward than doing it for numeric fractions. That's my opinion. I think this process is a little more streamlined. You might feel differently about it. So I've got this problem right here, example 3. I've got 7 over x plus 4 plus 11 over x minus 5. Can we all agree that those denominators are different? Yes. Yes. Okay, so I've got how many different factors in my denominators here? This is the key question. So if you don't know the answer to this, that's okay. I'm going to help you figure that out. How many factors are in the denominator of this one? There's 2 terms in the one factor. Remember, whenever you have an adding or subtracting, those things go together. So the x plus 4, those are joined. Can't separate them. The x minus 5 over here, those things are joined. That's a separate factor. So first thing I'm going to do is I'm going to identify the least common denominator. I'm going to cleverly abbreviate that, the LCD. And this is the best way that I can simplify this process or summarize it. I'm going to write this down at the bottom so we have room to do the problem. When you find the LCD of your algebraic fractions, what you're going to do is this. You're going to take let me put the LCD is one of each factor. And if there's powers, take the highest power. I'm going to repeat that a bunch of times as we go through the problems. Okay, that's as streamlined as I can make the process. Now, when we have coefficients, when we have numbers in front of a monomial, I'll show you what to do. I'll remind you of something you learned a long time ago, but probably have forgotten, how to quickly and hopefully easily find the common factor between 2 numbers. Okay. But for now, in fact, we already talked about that. I've told you that when we cleared the fractions, when we were solving equations a long time ago, I showed you how to do that, but I'll do it again because I want everybody to feel nice and happy and love the Perkster today. Okay, so when you find the LCD, when you find the least common denominator, you take one of every factor, and if any of the factors have a power on it, you take the highest power. Okay, so looking at this problem right here, I've got 7 over x plus 4, 11 over x minus 5. When I form my common denominator, tell me one of the factors I need. Sure, yes, I know you said that with some uncertainty, but you got it right. X plus 4, perfect. That's one of the factors. And tell me another factor that I need. X minus 5, I think that's what you meant. I'll forgive you because you guys forgive me when I make little mistakes like that. Yes, are there any other factors that I see in my fractions? No, that's it. Okay, so you just take one of every factor you see. If the x plus 4 happened to be raised to the second power, I would take x plus 4 to the second power. You take the highest power. Okay. Now, this is my process. I have to have a process. Okay. Otherwise, I will goof things up. Okay. That's something you don't know about me, or maybe you assume it about me. So here's what I recommend you do. First thing we're going to do is I'm going to take this common denominator and I'm going to write it down here one time for each fraction. Okay. So I'm going to take the x plus 4 and the x minus 5. I'm going to write it here for the first fraction plus the x plus 4 and the x minus 5. I'm writing it for the second fraction. You with me so far? I've got to take each of those fractions and I got to make it into a new fraction with the common denominator. So I can do what we did on all the previous problems. Any problems so far? Okay. Now I have to make my adjustment because I've just changed the denominators of both fractions. You can't just change the denominator without changing the numerator. They go hand in hand. Okay, so this first denominator, let's look at the fraction on the left. This first fraction had a denominator of x plus 4. It changes into this. What did I multiply the denominator by to get the common denominator? X minus 5. So here's what you're going to do. I'm just going to notate that. And then, so that means I'm going to multiply the numerator by x minus 5. The second biggest mistake students sometimes make is forgetting to distribute, because I know you're excited. You found the common denominator. You're happy. This seems easier. The Perkster is an amazing professor. And so what I'm going to do is I'm going to take that 7. I'm going to distribute it. 7 times x is 7x. 7 times negative 5 is negative 35. We good? I know this is a difficult process. Let's try to go slow. So here's what I want you to do. I'm going to give you 20 seconds. I want you to make the adjustment for the second fraction. Okay, the second fraction starts out with the denominator x minus 5. It turns into this. So what is going to be the new numerator? Don't shout it out. Write it down. We'll talk about it in a minute. All right, what do I have to multiply by to get from this denominator here to my brand new common denominator? That's the missing thing, x plus 4. Say it like you mean it. When you got the right answer, shout it out. Be so happy. So the x plus 4, yes, right there. I've got to squeeze it in. Sorry, I did not allot my space very well. That's one of my problems. So 11 times x is 11x, and then 11 times 4 is 44. Do I have a common denominator now? Okay, now we just did these other problems. No one asked me any questions. I'm hoping that that means things went all right. Once you do have the common denominator, it is as simple as adding the numerators and leaving the denominator alone. So 7x plus 11x is 18 of them. Negative 35 plus 44, that is what? Plus 9, I think, over x plus 4, x minus 5. Now you can factor out that 9 out of the top if you see that's there. You can. I'm not going to, because when I factor out the 9, it's not going to result in any factors that'll reduce. Let me show you that. Let me not just say that. Let me show you. When I factor out the 9, 18x divided by 9 is 2x. 9 divided by 9 is plus 1. So either form of that answer is correct. Either this one or this one. I will accept both. That one does not reduce at all. That's the process, and that's what we're going to practice for the rest of our class time today. Okay, that's it. So hopefully you're like, okay, I think I can learn that with a little bit of repetition. Let's do it. Flip the page. Exercise 6 is almost identical to exercise 5, or the example I just did, whatever it was numbered. You get to do it. So let's do this in phases. I'm going to give you 20 seconds. I want you to identify the least common denominator. Then I will let you work the problem. All right, what is the least common denominator? Somebody tell me one of the factors I need. Yes, that is indeed true. Y plus 2. Fantastic. Is there another factor that I need? Yes, thank you for telling me the truth there. I appreciate it. Are there any other denominator factors that I need? No, we're all out. You take one of every factor. If there's powers, you take the highest power. Okay, that's your least common denominator. From there, now write that down once for each fraction. Make your adjustments to the numerator, and then add them up. All right, so here goes. I'm going to get started. If you're working, keep working. Just trying to split the middle from people who are already done and people who are still working. So I'm going to write down this common denominator twice, once for each fraction. If there were 3 fractions, I'd write down the common denominator 3 times. And now I have to make my adjustments to each of these fractions. So the first one, I've got to turn the first one from the denominator y plus 2 into the common denominator. What do I have to multiply that first fraction by? That is right, y minus 3. Thank you very much. And when I do that, when I distribute, you should have 3y. 3 times y is 3y. 3 times negative 3 is minus 9. So far, so good? I'm hoping you would let me know. I'm totally open to questions, okay? This is a hard thing to do. Okay, this is probably, like I said, it's probably the hardest section in this unit. All right, the next one, I've got the denominator y minus 3. I've got to turn it into this. What do I need to multiply the second fraction by? Okay, thank you. Said with confidence. I like that. And so now when I do that, I have 4 times y is 4y. 4 times 2 is 8. Okay, that's the hardest part to the problem, in my opinion. The rest of this is fairly straightforward. I'm adding. I've got a common denominator, so I add the numerators, I leave the denominator alone. So I think I wrote down an x there, and you're probably wondering, why in the world did you change the variable? Sorry, that's just me. I love x's. Okay, so 3y plus 4y is equal to 7y. Negative 9 plus 8 is negative 1. Nothing's going to factor out of that, so nothing's going to reduce here. That's good. Less work for me. And then I have y plus 2, y minus 3 in the bottom. All right, we're just going to keep pressing forward until somebody asks me a question or something happens that's weird. All right, exercise 7. Again, I'm going to give you 20 seconds. Identify the least common denominator. Be super careful on this one. All right, so I've got my 2 fractions. I asked you to identify the least common denominator. What's one of the factors that I need in my common denominator? Yep, x plus 3, that's fantastic. What else do I need? Okay, yes, remember, this x right here has the plus 3. That makes something unique. That x plus 3 is different than this x. Okay, they are separate factors. Okay, it's like the number, if x was 4, this one would be 4 plus 3 or 7. Okay, different numbers. So I also need to have a factor of x in there. Those are my 2 factors. You cannot just have x plus 3 as the common denominator and then come over to this one and say, okay, I'm going to add 3 to the top and the bottom. That's not how fractions work. They can't do that. All right, so if you missed that, that's okay. That's why I put this problem on here to try to address that. Now that we've identified the common denominator, go through the rest. Write that once for each fraction, adjust your numerators, and then add them up. All right, I've written my denominator one time for each fraction that I started with, x and x plus 3. So the first fraction, what do I have to multiply the top and the bottom of the first fraction by? Just the x. Okay, that's what's going to make the change here. And so my numerator becomes just 5 times x, or 5x. And then what do I have to multiply the top and the bottom of the second fraction by? Okay, x plus 3. And in this case, since I have that binomial, I can't forget to go ahead and distribute. So my numerator is 2 times x, and then 2 times 3 is plus 6. Okay, that's the hardest step. Anybody got a question or a concern? All right, I'm going to add up those tops right there. So 5x plus 2x, that is equal to 7x. And then I have plus 6. There's nothing in common to those two terms. So nothing is going to reduce here. And then don't forget to write, oops, I don't know what I just did there. I was trying to talk and write, and that's never good for me. Don't forget to write your denominator, which is x times x plus 3. There's my fractional answer. All right, exercise 8. I wanted to give you a look where we have a monomial in the bottom of each. So here I've got 3x squared in one and 4x cubed in the other. So you're going to have two things to do. Okay, I'm going to give you 35 seconds to find the common denominator. You have to do two things. You need to first figure out what's the common factor between those coefficients of 3 and 4. Okay, that's the first thing. And then the second thing is, how many x's do I need? Okay, and I spoiled that secret earlier. So give it a try. And if you don't get this one, don't worry. Exercise 9 is going to ask us to do something very similar. All right, so my common denominator. I said you have two things to do when you got monomials here. I first have to figure out the common multiple between those two coefficients. What's the common multiple between 3 and 4? 12. Okay, in case you've forgotten how to do this, okay, this is something we did way back. The easiest and most direct way I can tell you in our very short time talking about this, how to find a common multiple, is by the listing method. Okay. And all the listing method involves is you take your two numbers, in this case 3 and 4, and you list out the multiples until you find the first one that they have in common. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and I can come back and I can always add on more. I'm going to stop, and I'm going to go to the 4. And 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Oh, there we go. That's the first one they have in common. We always like to use the lowest common denominator because it avoids headaches at the end of having to reduce. Okay, so I'm trying to save you a little time here, but you really could use any common multiple, but the lowest is going to be the best. So for my least common denominator, 12. And then my other factor is x. But I told you, you take one of every factor, and then if there's powers, you take the highest power. So what's the power of x that I need right here? X cubed. And hopefully that makes some sense. If you just took x squared, if you said the common denominator is 12x squared, this denominator has more. So what would I do if I already had more x's in a denominator? That would kind of tie me up a little bit. So I always take the most of my powers. So 12x cubed is your common denominator. From there, do just what we did before. Write that once for each fraction, adjust the numerators, and then add them up. Okay, so my common denominator is 12x cubed. So looking at the first denominator, starts off as 3x squared. What do I have to multiply 3x squared by in order to make it into 12x cubed? 4. Okay, 4 and an x. 4 times 3 gives me 12. The x times the x squared gives me x cubed. So 4 and x. And when I multiply that in the numerator, I got 4x times 2, that is 8x. All right, what do I have to multiply 4x cubed down here by in order to make it 12x cubed? Excellent, well said, 3. And so my numerator becomes 7 times 3 or 21. At this point, I want to pause because sometimes when, especially in the problems that have monomials as denominators, students will see these fractions now and say, oh, those aren't reduced. And so want to reduce them at that point. That's not what we've done is we've intentionally unreduced the fractions so that we can have a common denominator. So if you reduce these fractions now, you're going to then not have a common denominator anymore. So avoid that temptation. We only reduce at the very end of problems. Okay, so now I'm going to add these up. I've got 8x plus 21. Those are not like terms. So I'm going to just have 8x plus 21. There is nothing in common to either of those terms. And then I have 12x cubed in the bottom, and that is my fraction. All right, so that's adding. We have another adding problem at the end of the section. I think there's one or two, but I just want to make sure that I cover an example of subtracting. So this is my example. I'm going to do this one. You're going to help me a little bit though. First thing we're going to do is we're going to find the common denominator. So I'm going to give you 22.5 seconds. I would like you to please find the least common denominator between those two fractions right there. Just because it's subtraction, that's no different than before. All right, somebody tell me, what is my least common denominator? Bring it on. Okay, sounds good. I hope everybody wrote that down. You're all just too shy and tired. It's Thursday. There's only 6 weeks left in the semester. I get the confluence of all those things. All right, now what I want you to do is what we've been doing before is go ahead and create 2 new fractions with that common denominator. And then if you feel confident about subtracting, go for it. If you don't, we'll do that part together. All right, so the first fraction, I've got to multiply by x minus 6. This is the exact same thing we've done a bunch of times. So if you're wondering where that came from, that would be a great question to ask me. So 5 times x is 5x. 5 times negative 6 is negative 30. Then the second fraction, I'm going to multiply by x plus 4. That's the other factor. And so then I have 2 times x is 2x, and then 2 times 4 is 8. The only difference in this problem than any of the previous ones is this is a subtraction, so you have to find whatever way you can to remember we're subtracting everything that comes after the subtraction sign. So for me, this is how I remember to subtract everything. I'm going to add the opposite like we did on the front page. So I'm going to change this to an addition, and then I'm going to change the sign of everything that comes after. So instead of 2x, I have negative 2x. Instead of 8, I have negative 8. Now I'm ready. 5x, negative 2x, that's 3x. Negative 30 and negative 8 is negative 38. Nothing factors out of those two terms, so there's no reducing to have to do. And there's my final answer. The key to getting good at these problems is just realize you're doing the same thing every time and just do it the same way every time. That way, when you get here on the test, it's just like an assembly line, and you're doing the same steps every time. Yeah.
You don't distribute the negative signs into the denominator?
No, because the denominator, when you add or subtract, the denominator stays the way it is. You don't do anything to it. Okay, so only the numerator is what gets affected when you add or subtract. Great question. I love that clarifying question. Okay, exercise 9 has denominators that are similar in structure to exercise 8. So if you learned something in exercise 8, you're good. So go ahead and do exercise 9. Again, 15 seconds. What's the common denominator? And then you get to do the problem. All right, so I have 5x squared, I have 6x to the 4th. They're both monomials. So firstly, what is the common factor of the coefficients? Yep, 5 and 6, the common factor is 30. Fantastic. And then the other factor I have is x's. And how many x's do I need? You need 4. You always take the highest power. Great. Now take that common denominator and subtract those fractions, please. All right, so the first fraction starts off as 5x squared. I've got to turn it into 30x to the 4th. So that means I'm multiplying by 6x squared right there. And when I multiply the numerator by 6x squared, 9 times 6 is 54x squared. The next one, it starts off as 6x to the 4th. I've got to turn it into 30x to the 4th. So that means I multiply by 5. I don't need any more x's on that one. And in the numerator, 7 times 5 is 35. There's my 2 new fractions that I'm subtracting. And now I will do that. And when you subtract and when you add and subtract the numerators, you leave the denominator as is. So my numerator is 54x squared minus 35. Those are not like terms, so I can't do anything with it. nor does anything factor out of those two terms. So I don't need to do any reducing here. And then I have 30x to the fourth in the bottom. There's my added expression. I've combined two fractions into one new fraction. All right, so I'm hoping I've put a lot of problems on this because I know students, this is one of the areas of struggle. And when you get to college algebra, you're going to need to know how to do this because we don't have time to teach it again in there. So I'm hoping every one of these we do, it becomes a little more familiar, okay, a little less intense for you. So exercise 10 is very similar to everything else we've done, 6, 7, and example 4. So go ahead and do exercise 10. Go all the way with it. I'm not going to make you declare least common denominator. I'll write it down in about 20 seconds and you can check. But just keep working. Go to the end of the problem on this one. All right, so the common denominator is just one of every factor. So x plus 4 and x minus 7, I need both of them. So I wrote that common denominator underneath each fraction. I've got two fractions on this problem. The first fraction starts off with x plus 4. What it's missing is the x minus 7, so I'll multiply that. And when I distribute, the only difference in this problem and the other ones is I have x's in the numerator, just to make it look a little different. Okay, so 2x times x is 2x squared, and then 2x times negative 7 is negative 14x. Same thing in the other one. This fraction starts off with an x minus 7 in the denominator. And so it's missing the x plus 4, so I will multiply by that. And when I distribute, 3x times x is 3x squared, and 3x times 4 is 12x. Again, I notice I'm subtracting. My way of remembering to subtract everything is I'm going to distribute this minus sign. It becomes a negative 3x squared and a negative 12x. And here we go to the finish line. 2x squared and negative 3x squared is negative x squared. Negative 14x and negative 12x is negative 26x, all over x plus 4, x minus 7. There is my added expression. I'm going to leave that up there for anybody who's still copying down the remnants of that, but turn the page, do the next one. Exercise 11, please, at the top of the page. Only difference in exercise 11, the back of the page is just some extrapolation. The only difference in that one as opposed to exercise 8 or 9 is there's an extra variable. Okay, just to see if you're following along with the taking the highest power part. All right, my least common denominator. What's the lowest common multiple between 12 and 8? 24, yes, indeed. Now, again, you could use a higher multiple. Things will work out fine. You're just going to have a little bit more reducing to do at the end than I may or may not have. Okay, I need a factor of x. How many x's do I need in my common denominator? What was that? 5, okay, thank you. Just didn't hear you, sorry about that. And then how many y's do I need in my common denominator? Y cubed, you always need the highest power of each. Okay, so that's the common denominator. I'm gonna give you another 30, 40 seconds to go ahead and make as much progress doing the adding as you can. Right, on this particular problem, I'm turning my denominators into 24x to the 5th, y to the 3rd. The first denominator is 12x to the 5th y squared. So I see that to make the 12 into 24, I multiply by 2. I've already got the x to the 5ths. That's fine. To turn the y squared into the y to the 3rd, I multiply by a y. So this first fraction, I'm multiplying by 2y. So that makes the denominator 5 times 2, or 10y. The second one, to make the 8 into 24, I got to multiply by 3. To turn the x to the 4th and the x to the 5th, I multiply by an x. And then I've already got the y to the 3rd. That's just fine. I don't need to do anything there. So in this one, I'm multiplying by 3x. So on that fraction, 3 times 3 is 9x. Now I'm going to do my subtraction. I've got a pair of monomials, so I've got 10y minus 9x. Nothing is common between them, so there's going to be no reducing to do. If you used some number other than 24, then you do have a common factor that you've got to take out and reduce. But I saved myself a little work by using the least common denominator. All right, next problem. Okay, we're approaching the finish line. Okay, so if you got any questions, be sure to ask it. I don't want you struggling more than you need to on the homework. So exercise 12, I've got these trinomials as denominators, and we're not going to make the common denominator the multiplication of these two trinomials. Here's what you're going to do first. I'm going to give you 30 seconds. Factor both those trinomials. I'm just going to write it real small underneath each fraction. What do I get when I factor each of these? All right, so the first denominator, I need the two factors of -3 that add up to -2. What are those? Okay, -3 plus 1. Great. The second one, I need the two factors of +6 to add up to -5. What are those two factors? -3, -2. I want you to notice when we get to exercise 14, I kept the same denominators to save a little bit of time. Okay, so stuff you won't have to redo on that problem. All right, I'm going to give you 12 seconds. I want you to identify what are the factors that I need in my least common denominator. Remember, we take one of every factor we see. How many factors is my least common denominator going to have? 3. There are 3 factors here. I need an x minus 3. I need an x minus 2. And I need an x plus 1. And you can write those in any order, okay? It doesn't have to be the same order as me. There's the common denominator. So now the rest of the process is the exact same thing we did before. Take that slightly longer common denominator, write it once for each fraction, change the numerators, and then add them up. At the first fraction, I've got x minus 3, x plus 1. It's missing the x minus 2, so I multiply this first fraction by the x minus 2. And so then when I distribute, that's 4x minus 8. The second fraction, I've got x minus 3, x minus 2. It's missing the x plus 1, so I multiply by x plus 1 here. And so when I distribute, that's 3x plus 3. Now I'm ready to add. So 4x plus 3x, that's 7x. -8 plus 3 is -5. There's nothing in common there, so there's nothing to do. And then do not take the time to remultiply. That would be crazy. Just go ahead and write down your common denominator, and there it is. That's done. 7x minus 5 over the x minus 3, x minus 2, x plus 1. All right, my purpose in exercise 13 is all these problems we've done have had 2 fractions. This one has 3. Again, I'm just attempting to show you the process is no different. So here's what I'd like you to do. One of those denominators can be factored. So factor that denominator and then tell me what the LCD is. Okay, so one of the denominators can be factored, factor it, and then determine the LCD. And then you can keep going if you want, or you can stop and wait for me. All right, which fraction has the denominator that can be factored? The third one. Yes, everybody is so quiet today. I know I'm boring. I get it, but that's okay. I'm making this as exciting as possible. So that last denominator, I'm factoring the x out of it, and I've got x, and I've got x minus 3. Great. So now I've got 3 fractions. I can see all the factors, and then we can identify the LCD now. Tell me what I need in my LCD. I need an x minus 3, that's for sure. I see that in the first fraction. I also see it in the last fraction. And then yes, both were given to me. I also need an x. I can see an x in the second fraction and an x in the last fraction. So there's my least common denominator. All right, I'm going to give you 60 more seconds. I want you to now write that instead of 2 times, you're going to write it 3 times because there's 3 fractions, and change the numerators and then perform the operations. All right, so the first fraction is x minus 3 in the denominator. The common denominator has both x and x minus 3, so you can see it's missing the x, so we'll multiply by that. So the first numerator becomes 5x. The second fraction just has an x in the denominator. It needs to have an x and an x minus 3, so I'll multiply this second one by x minus 3. X minus 3, squeezing it in there. And when I distribute, I've got 2 times x is 2x, and 2 times negative 3 is negative 6. The third fraction, is this third fraction missing anything from the common denominator? No, it is not. So I don't need to do anything with that third fraction. It's going to just stay 6. All right, and now let's add everything up or subtract or whatever we're supposed to do. I've got 5x plus 2x, that's 7x. I've got negative 6 minus 6, that's negative 12. There's nothing in common there. So there is my reduced fraction. All right, here's what we're going to do. Just because I don't want to have to rush and make anybody feel any more uncomfortable about this. So we're going to do exercise 14. Exercise 14, notice, has the same denominators as 12. I did that on purpose. So the common denominator is going to be the same. So I want you to finish that problem. I want you to subtract those 2 fractions. You're going to have to do a little foiling. And then I'm going to let you go. I'm going to do exercise 15. I'm going to post it as a video on Canvas. So before your homework, you can take the 3 or 4 minutes, maybe give it a try on your own, and then check it out. And then you'll be ready to do your homework. You'll see everything you're going to see. All right, so these denominators are just the same as example 12 right above. And so in example 12, we saw that the first fraction was missing the x minus 2. So I multiplied this one by x minus 2. The difference, and the reason I'm giving this problem, is what to do when I have binomial numerators. I think this is the first time this has happened for us. So I just didn't want to skirt the issue and make sure we're nice and clear. So I'm going to take the x minus 2 times the x plus 4. I'm going to FOIL. So my first, x times x is x squared. My outers, x times 4 is 4x. My inners, negative 2 times x is negative 2x. And then my last, negative 2 times 4 is negative 8. And we'll collect like terms and do all that good stuff in just a minute. The second fraction, when we look up at exercise 12, we see that this was missing the x plus 1. So again, I'm going to just FOIL. So 2x times x is 2x squared. My outers, 2x times 1 is 2x. My inners, negative 3 times x is negative 3x. And then my last, negative 3 times 1 is negative 3. I am subtracting on this problem. You are welcome to collect the like terms first if you want. I'm just going to go ahead right the way it is. I'm going to distribute that negative, then I'll collect all my like terms and we'll be at the finish line. So since I'm subtracting, I'm going to add the opposite. So I change this to a negative 2x squared, a negative 2x, a plus 3x, and a plus 3. And here at long last is my answer. I've got x squared and I've got negative 2x squared. That's negative 1x squared. I've got 4x minus 2x. 4 minus 2 is 2. 2 minus this 2, that's 0 x's. And then plus 3, that's plus 3x. And then negative 8 plus 3 is negative 5. Since negative 5 doesn't have any factors, nothing's going to add up to 3 there, so there's no way to reduce this. There is my final reduced expression.